So, good afternoon to everybody. Welcome to the third of the NEBgS South Lecture Series. This is an initiative that we are leading here at FAUP that involves all the 5 schools of architecture placed in the south of Europe. And the idea of the NEBgS South Lectures is that they organize other lectures that are going to be broadcasted online as this one. So we have some people here in the Zoom, some people here in the audience, some people coming, and thank you all for being here. I'll ask Luis Gama to present our guest for this interesting lecture about bamboo and the future of design. So, Luis.
Hi everyone. It's a pleasure to be here. Well, first I was a student, then a tutor here also, and it's a pleasure to bring a friend to this stage. Jörg is a carpenter. He's a builder. He's also a designer. It's a designer from another era. Jörg is it's from the era of the master builders, with a deep knowledge of the chosen construction material and his craft. Jörg was born in Germany into a family of builders. He dedicated himself to structural and furniture carpentry, and in the 90s he moved to Colombia. It was in this country that he discovered bamboo, and he decided to settle there. With over 30 years of experience, he is considered by his peers one of the more experienced builders, bamboo builders in the world. Among his most well-known achievements are the first bamboo structure, big structure here in Europe. It was the Zeri Pavilion in Hanover, and the iconic Green School in Bali, and more recently the gymnasium at the same school that won an engineering prize with the firm Atelier One, this Supreme Award for Structural Engineering in the United Kingdom. In addition to these incredible constructions scattered all over the world, Jörg has organized numbers of bamboo workshops and trainings all over Asia, Latin America, Africa, and now Europe. And that's why Jörg is in Portugal right now, because we have he's going to lead a workshop in Alentejo next week with Bamboo Park, and we have the privilege of having him here, us today, to talk about bamboo, his extraordinary experience with his plant and also building material. Thank you, Jörg, and thank you, everyone.
Better, yeah, to appear. But if you want to point out something you have here, and let's do that.
Tá bom. É melhor. Boa tarde. Eu não falo muito português e também para a audiência internacional vou falar inglês também por respeitar o português, porque eu falo portunhol. Então é uma misturança não muito clara. Também por os términos tecnológicos é melhor em inglês, não? Então, thank you very much for inviting me, especially to Luis, Luis da Gama, who was giving me a hand to come here and showing me the beautiful city of Coimbra, and I hope tonight I will also meet a little bit of ancient flair of the grand nation of Portugal. I've always been inspired about your achievements as sailors and navigators of the world. And as I'm a carpenter by trade, I always respect the shipbuilders, and we know that behind each big conqueror or conquistador or whatever you call your navigators, there is a bunch of shipbuilders who make it possible that the oaks and the other trees from the forest become a ship. A ship is a very complicated building. It's the highest level of architectural achievement that you could, if you are a ship carpenter, you are the highest level of imagination and three-dimensional design. And I did a ship actually when I was working in Sweden. I did a Viking ship together with the anthroposophic school, with those Steiner schools. They did that as a project in their school to teach children about a hands-on project, which for me became one of the best ways to learn about mathematics, about physics, about biology, about all the sciences that you can learn. Project-oriented learning, and as I'm a carpenter, I learned by trade. So there are at least 800, maybe 1,000 years of trade unions, of guilds that transfer knowledge hand from father to son or from master to apprentice. So that's my upbringing. I'm coming from a hillbilly village somewhere in Germany, so that was my only chance to make a career. And now I'm traveling all over the world, especially over the tropical belt, working on bamboo. How did that come? Well, in the 80s, we were trying to avoid the imports of tropical hardwood from Africa or from Brazil or from Indonesia. We were trying to save the orangutans and the gorillas and the habitat of wildlife in general. So we achieved that tropical hardwoods were banned from public licitações, from public tendering. We achieved that, although nowadays it's all thrown over. Now all these big achievements like going against atomic industry and going against war machinery, all that in the last few years banged down, and it's now like it was in the good old times of Cold War. Well, we don't want to talk about this, but I want to show that life comes in circles, and I'm pretty sure that there is a future for carpenters, not only for architects, but also for builders. Design has a design component, but it also has it needs a deep understanding of building, of how to do things. Otherwise, architects cannot survive in this world, because designs may be soon more influenced by artificial intelligence than by knowledgeable hands. So I want to show today a little bit of a variety of how to work with bamboo. Why bamboo? Because I didn't want to work with tropical hardwoods. So my way of looking into an alternative of tropical hardwoods was to work with tropical grass, giant grass. Bamboo actually is a grass plant, sometimes only 30 centimeters high. Some species are small bushes, and other species can have the size of an elephant leg, and they can be 35 meters long, 35 meters high. Bamboos are pioneer plants in the tropics, so if you cut down a big tree, most likely the bamboo plant within 1 year shoots up all the way up to the canopy and seals the wound in the forest. That's the ecological niche of bamboo. So bamboo is a very fast-growing plant. There are bamboos in the tropics and there are bamboos in the subtropics. Mostly we think about China as being the origin of bamboo. This is not true. 460 species of 1,200 species are, for example, endemic or native in South America alone. So Brazil, we have people from Brazil here, I think, and from what other countries? What else is your interest here? I've not even asked where you come from, but I think it's not only about construction in tropical countries, it's also the question about what are we doing with bamboo in the European context, and we don't want to forget this part of this lecture, so we will see some examples. Okay, here this picture is from the ARC. It's the Green School Bali. I was working for 7 years with John Hardy, bringing up the baseline, the structural baseline for the Green School. I worked in a team with different architects and designers and with the Hardy family, so we reinvented bamboo constructions because traditionally in Bali everything is very squared. And John Hardy said, you can do everything, just don't do a box. John Hardy is a Canadian guy who was one of those hippies who got stuck in paradise. So he lived there, made his fortune with silver, and then he decided for his kids, I need a proper school, I need something which is unboxed. And he supported a lot of designs that were just completely out of the trend. And this big structure here got an engineering prize last year because of its intricate design yet simple concept. It's basically the same like a rickshaw or like a children, how do you say this, in a chariot. I think the name is a chariot. Traditionally you have those foldable tents over a chariot, and that was the idea to come up with this structure. We will see it later in detail, so I will start now. There is a question, how can we build with bamboo? What is the intricate quality of bamboo? If you want to say it in 3 words, it's basically long, light, and strong. It's like a steel tube, but it's naturally growing. It's slender, so it has a strong loading capacity upside down, but it is not very good if you talk about bending. So in terms of bending, you have to crisscross it. And lately I came up with these kinds of designs. This is actually in Brazil. These buildings, they started with the towers at Green School, like hyperbolic cylinders. But now I'm doing lots of those hypars, those hyperbolic paraboloids, which are surface active shapes that can be structurally very sound. The same if you have a Rolls-Royce car or whatever kind of well-designed car, the curves of the car, they speak a lot about aesthetics, but at the same time they are strong. Yeah, like the bumper of a car is just a bit of a folded piece of metal, but it's folded in the right way or rolled in the right way, so it's very strong and can absorb impact. So it's all about long, light, and strong, and I think this is what we're going for in engineering and architecture. If we talk about bamboo, we have to bear in mind that this grass is long, light, and very strong if used accordingly. There's another design feature, which is nature. As you can see, there's a big mountain range in the background, so it's about 3 volcanoes over Bali, watching over those rice terraces, and John Hardy needed a factory expansion. This was in 2007 when the world was expanding like crazy, and nobody had any idea that in 2008 the big economic crash would come. So John Hardy commissioned an expansion for a new factory, and he said, the biggest impact in my business is air conditioning. So I need some kind of building that takes in mind the insulation for air conditioning. And I thought, okay, there may be even a smarter way if you just avoid heat building up within the building. So if you see, there are 3 towers and they have 3 volcanoes and they have an opening on the top, which is normally the crater lake. And the 3 towers are connected by yokes. So you can see curved bamboo is used for some part of the constructions and straight bamboo is used for others. But what is interesting, you can see here, there is cement injection, there is cement mortar grouting, and you can see there are screws. There are metal screws, so-called threaded rods, going through the bamboo. And these threaded rods, they would act like a knife on the thin walls of the bamboo. But there was one very good invention, usually attributed to Simon Velez, a Colombian architect, who came up with this idea to put a cement mortar injection just in that node where the metal screw is. And he discovered that he tenfolded the load-bearing capacity of that joint. So normally if you do a crisscross joint, you put a screw through it, the capacity of the bamboo would be, let's say, 150 kilos, 200 kilos, and then the bamboo would basically slice. But if you put cement mortar in both of those hollow spaces inside, the whole compression force of that screw will be led to the next diaphragm. It will be basically distributed on the whole ring of the diaphragm, and it tenfolds. It will go for 1,500 for a ton or for 1,500 kilos, just because of this 1 kilo or 2 kilo of cement being injected in the holes. That was a major difference between traditional bamboo architecture, traditional tribal bamboo design, and engineered modern design. That little detail makes all the difference. Together with a treatment process, a previous process of selecting the bamboos, putting them into a saltwater pool for a week, and that salt water usually has to be borax or sodium pentaborate or boric acid or something bitter. It has to be a bitter salt. Normal sea salt would work also, but you have to put it much more time and in much higher concentrations. So scientifically proven that bitter salts work much better because insects, especially xylophagos or wood-eating insects, they don't like the pH change. So if you change the pH level of wood, the microbiology of the insect's stomach doesn't work, and they eat a bit of bamboo and they just die. So it's a very soft way of treating bamboo without harming the client. Sometimes you hear about CCA treatment, you know, these green poles they use in wood. CCA is chromium, copper, and arsenic, and that's very toxic. Yeah, so you don't want to do that, especially not for children playgrounds and stuff like that. So nowadays we are using borax instead of arsenic. It's not anymore water resistant, so you have to do the borax treatment against the insects. You can use a roof, like a big roof overhang and elevated structures to protect them against water. So the engineering pretty much is the same engineering as if you would do a metal engineering or a wooden round pole engineering. The stress basically is on the joints, and there is a little bit of an issue with the slenderness. I think in English the effect is called buckling. So how can we avoid buckling is just by using a lot of those crisscross. So all the compression elements in red, all those compression elements, they definitely have to have a lot of crisscross, reduce the space, and the tensile elements here in blue, those tensile connections, they have no issues, you know. Tensile, bamboo is like a steel rope or like a rebar. It has pretty much the same tensile capacity. We're talking here about a tensile capacity of 2 tons per square centimeter. The compression is around a third, means something like 600, 700 kilo per square centimeter is the compression capacity in the fiber sense. And if you go perpendicular to the fiber, it's something like 60 kilos, 50 to 60 kilos. So you see these 3 values, they will give you a very good indication for your calculations. I repeat, 2000 or 2100 for tensile, 700, 600, 700, depending on the species, for compression in fiber direction, and 50 to 60 perpendicular. Okay, so what's the interesting thing to build with bamboo? You have to see it, separate the straight poles from the curved poles. If you have straight poles, you use it for compression elements, for example, while slightly curved poles, you can use it like for tensile elements. Here I use the tower. It looks like a curved tower, but this is a hyperbolic cylinder, so it's basically, it looks curved, but it's made with totally straight poles. It's a ruled surface with straight poles that creates the cylinder, and it creates a very interesting effect. Even with the skylight, you can leave light in. And yeah, here, this is the latest design winner, the Arc. It went through many, coffee table books and magazines, architectural prizes. It won about 7 architectural awards. It's designed by Ibuku. Ibuku Architects is basically the daughter of John Hardy. Her name is Elora Hardy. She inherited the empire and she does the design. But she obviously has 50 or 80 architects working for her. And I'm helping to guide that crew of people if there are challenging projects. So you can see here a few pictures of Green School. In the back you can see the heart of school, which is similar to the building I showed in the beginning. And nowadays we have this tendency to do curvy structures, not like Kohlhaas or whatever, like those squared boxes. I think these modern architecture, or what once was modern architecture, nowadays is replaced by something called contemporary architecture. And astonishing enough that this contemporary architecture is usually very crooked and very curved. It's more about the smoothness and the beautiness of those curves. And the thing is, it is very difficult to build. If you have a straight pole, how do you build those arches? And the trick is, in the very beginning of a construction, I separate between the straight bamboos and the crooked bamboos. So I make 2 piles, 1 truckload of crooked bamboos and 1 truckload of straight poles. So the straight poles, they are never totally straight, nor ever totally curved. It's somewhere between. So I cut certain sections out of the curved and join them. You can see here there are 5 or 6 bamboos jointed, and sometimes we do little incisions to help out a little bit to get the right curve, but that is something we shouldn't do too often, because you need, for each incision that you do in the bamboo culm, you have to repair it, and this is an additional cost. So you can see we, according to Atelier 1, who actively took part in the development of this huge building, we took a lot of testing up front. So how much is the deformation under load? And there is something very interesting. You can see here there are arches, but also those splits, the splits that connect like from one of those ribs to another rib, those split strings, they behave like cables, like steel cables. They are tension elements. They are like tendons. If you would say this is a rib structure, you could compare it to the body, like a chest, like a rib cage. And between the ribs, you have skin, you have tendons, muscles that connect each rib with each other. That's why the rib cage becomes so strong. It's flexible in a way, but at the same time, it has incredible strength. So you can see that those curves, they are not just curved because the designer wants to have it curved. There is an inherent logic. In each of those curves, you have to imagine a membrane, and the membrane is tensioned always. You can see it here. The tension has to go always from this tip to the tip down here, and from this tip to here. This is very important. The lines, like here, for example, from this point up here in the high, you go curved to the other side. So here's a convex curve, and here's a concave curve. But the convex and the concave strings, they hold each other and compensate in a way. So this is an engineering principle very well studied by Frei Otto. I had the pleasure to work with Gernot Minke. I also met Frei Otto in his laboratory in Stuttgart in his last years when he was still active in the Lightweight Institute. So Gernot Minke transferred to me the basic knowledge, which is Gernot Minke was the first assistant of Frei Otto. So he wrote a book about bamboo and he worked together with me for a while, so I learned about those principles. Yeah, and by the end of the day, you have these kinds of logic. The ribs and the membranes, they make the building strong, and they make it also light. It's an extremely lightweight structure. It was also extremely expensive. I think $780,000. That's a lot of money for a third world country. You also have those little breathing holes up here. Structures need to breathe. You have to have air circulation, the same as in my towers. Hot air in tropical countries, hot air rises. If you create an outlet, automatically fresh air comes in from the sides. So it's like a big air conditioning machine. If you leave outlets on the top, actually these outlets are a little bit too small, they should have been a little bit bigger. If you create outlets, always fresh air will come in from the side. That's why we cannot build in hot countries, we cannot build pyramidal roofs. Even if we have heavy rain, there should always be an air outlet on the top somewhere, like a little roof on top of the rest. Just leave an air gap. It's very important for tropical countries. Here you can see beautifully how those curves, convex and concave curves, work. It's called an anticlastic membrane structure. I think we should move on. Just enjoy the last photos. Yeah. It all started, my first international building was this one here in Florida, USA. It's the Vero Beach Botanical Garden in 2004. We prefabricated these columns in a typical German way, no? Straight, strong, combined bamboo poles, everything prefabricated, everything nicely, every screw, every little borehole was already prepared. I put that in a container. I went to the US, and in 2 weeks, with some guys there that I picked up at the street, well, not at the street, there is an office called an Office for Rented Drunks. Rented drunks are those people who have lost their driving license, and usually they are carpenters, they are cabinet builders, they're all kinds of qualified people, but they can't drive. So you just drive to the office where they are organized, and then you pick up a few and you pay them whatever, $10 an hour, and you take them to the job site. An interesting phenomena. But the nickname is Office for Rented Drunks. But nevertheless, they were very, very hardworking people, and within 2 weeks we built this. Why? Because it was all prefabricated up front. But you can see that this is a typical German building because it's very straight, it's very squared, it's just where I started. This is what I learned in Europe, this is what was my upbringing, were linear buildings, repetitive trusses, like we all do. Engineering is basically the essence of repeating straight lines. And yeah, I show that because I had finished this thing in August. In September, a hurricane came by, category 4 hurricane, 240 kilometers an hour. He whipped through the town, he ripped off hundreds of roofs, he laid down all those trees. There was not one tree, no palm tree, nothing left after the hurricane. But this structure stood as if nothing would have happened. There were like 25 palm fronds that were ripped off. We could nail them back very easily. What happened? First, it was proving that this structure was very strong. It was very, very well based on those concrete footings and nicely anchored with steel rods going from the bamboo into the ground. Those spaced columns are incredibly strong. So this is the perfect transition from the typical way how we do bamboo, wooden constructions in Europe. So all that worked very nice. And they had this curious Indian Seminole thatching. The palm leaves actually, when the wind came, the palm leaves, they all raised up like standing hair. They went up and the pressure in the building just went out. So it's an interesting thing when you have to build stuff for hotels in the tropics or so, think about hurricanes. We usually don't think about heavy winds in those areas, but there are easily winds of 200 kilometers an hour, more than we have here. And usually the locals, the tribes, they know how to handle these kinds of thatches or these kinds of roofing techniques. There was one other very interesting aspect. This is the first fully signed, engineered bamboo building in the US. And how we did that? Well, we went around the bush because Chief Andrew, or whatever was his name, the Seminole chief who did the contract for the roofing, he was basically saying us, yeah, if you pay a little bit more, I can validate this building as a typical Seminole indigenous building. And if you do traditional buildings in a country where the Indians, well, the American Aborigines would be supposedly the owner, they can basically sign off any kind of contract if they have their chief signing off the responsibility, the warranty. So it's one very elegant way of getting around the bush. But nowadays, there is this company called Bamboo Living. Bamboo Living, owned by David Sands, an architect from Hawaii. After $500,000 of testing, he went through the material testing, office or whatever. Like universities usually they have, or engineering universities, they usually have these testing laboratories. They have to sign off a material. So if we would like to have bamboo established in Europe as a building material, we have to go through a series of testing. And this is actually in process. So David Trujillo in, I think, Imperial College in somewhere in London or in England, Coventry, I think, yeah. He is working on it. So we have already a Eurocode for bamboo. It's just not yet out, but it's coming out within the next month. We're actually having a big international meeting in Rotterdam in a month, talking about those things. It will be very soon that we have the officially validated parameters to do bamboo designs in Europe. But this was 20 years ago in the US, and the only company since then who achieved similar effects or outputs is this company Bamboo Living. They have buildings that are certified everywhere in the US. They are according to the building codes. They are prefabricated in Vietnam, and you can get a loan on those buildings everywhere in the US. So that's a big achievement. I think they are a little bit ahead of us, but I think sooner or later we will get there too. Obviously, there are more issues than just structural buildings. There is heat, what is it called? Heat insulation in the winters and so on. No? Here in Portugal, not such a big deal, but in Northern Europe, big problem. Another very squared building is this one. It was done after an earthquake in Ecuador. We just, with the university and some local carpenters, we did this building. Also very based on the experiences of these composite columns, those composite columns of 4 poles creating one strong column. Yeah, this is absolute earthquake safe and very easy and very fast to build. We did a lot of other squared structures, like this is supposedly a storage place for a plantation in Mexico. But the owners that initially commissioned a storage building, they all of a sudden said, oh, this is so beautiful, let's make a restaurant out of it. So you see, those buildings are multi-uso, whatever it is in English. Yeah, very easy to build such a building. The structure alone is 2 weeks of work. It's not a big deal because bamboo is already finished. Bamboo comes ready to build out of the forest. You just have to dip it in a pool for a while and dry it again, and then you can basically assemble it. There is a quality selection, yes, maybe 30–40% of the bamboo poles make it through the quality selection, but it is wonderful. You don't have to go through a sawmill, through a lumber mill. It's just ready to build. So I find it very ecologic to work with round bamboo lumber. Now you see there is already a slight transition. All those squared, straight poles, now I'm already having a little bit like curved poles. They are slight curves. And those slight curves only create an arch if you have very big spans. Now, I cannot make a quick curve, otherwise I have to do incisions. But I can make long, slightly bent curves like this bridge. So as I told you, I separate straight poles, curved poles, and then I assemble the bridge. Here you have clearly your straight elements and you have curved elements. This bridge was completely prefabricated on the side of the road. Then a big crane took it up and put it on the foundations. So there were only 2 hours of roadblocks. And then we put the tiles on the roof. These are heavy ceramic tiles. So imagine, this is a 30-meter bridge, free span, with concrete floor and heavy ceramic tiles. Bamboo has incredible load-bearing capacities. So my job basically is teaching locals how to build with bamboo. The problem is rather, I think we should teach them also how to use a bridge. It's a dirty joke because this guy is putting the last tiles on the ridge beam. But yeah, it is a problem. People usually don't use bridges. Whenever I do bridges for rivers, yes, they do use the bridges. If I make bridges over roads, nobody uses bridges because they have to walk up and walk down. No, it's easier to cross. So I don't do road bridges anymore because it's just a waste of time. It's not possible to go against human logic. Well, 30-meter bridge, 1930, oh no, what is it, 1630. This is 1630, and this is 2010. So 300 years later. It's the same style. You see arches, cross in the roof, cross in the roof. Diagonals that take the tension, diagonals that go tension-wise. So, as a carpenter, we all know by trade, we learn how to build those kinds of structures. We have never gone to engineering school, it's just inherent in the guilds. We have this training of how to do trusses and a little bit of practice and you can build bridges. And the same thing I'm applying to bamboo. So it wasn't that I invented the bamboo bridges, I just changed the material and did a few adaptations according to the trick with Simon Valles and these cement mortar injections and so on. So you see, it's a very German bridge. It even has a German flag because it was financed by the German ambassador. But it's a very traditional system. It looks maybe complicated to you, but this is basic engineering. Every metal engineer, every civil engineer would be able to design such a bridge if he has the parameters. Okay, so different topic. Once being in Sumatra, once being in Indonesia, because of this thing, 2004, there was the tsunami. So the tsunami washed away a few villages in the north of Sumatra, and I was sent in to help out, to rebuild houses and do a little bit of reconstruction with UNIDO. UNIDO is a UN organization for industrial development. So my job was to train people to build with local resources because everything has destroyed and they had to come up with shelter. So we choose bamboo. And a little bit later, with the same guys, we did this hotel for a Swiss foundation. Paneco is basically saving the last orangutans. So they bring in usually red-haired Dutch tourists, put them in a hotel, charge $500, and then send them a few days to visit their ancestors, which are also red-haired. And they just need a little bit more luxury lodging. So I tried to, together with the Swiss architect, Lukas Sollinger, we came up with this design, a mixture between the natural stands of bamboo, and you can see here the typical triangulation of medieval craftsmanship. So you can see also here on the floor, these are the bamboos that cracked. I told you that 30% are good quality, but then you have another 40, 50, 60% that are not so good. They are cracking. So we sliced all those with a knife or with a saw. We sliced those bamboos and converted it into a split flooring. So later I can show you how it's made. So basically all the good bamboo is used for the structure, and the little bit less good, the second quality of bamboo is is used for the flooring. And yeah, furniture is also in bamboo. It's all bamboo. So it's a very, very beautiful eco-resort in Sumatra. It's called Bukit Lawang. It's obviously called the Eco Lodge. What other name would you choose nowadays? You know, those 20 years ago, that was a pretty unique feature, but now everything is called Eco Lodge. And that's the bridge. Well, that's a bridge in Green School, Bali, using different bamboos. You can see black and yellow, and we have a whole range, brown bamboo. You see how the contrast can be used. You see also the different sizes of bamboos. The yellow one is Dendrocalamus asper. It's a 35-meter long bamboo, up to 25 centimeter in diameter. And the black bamboo, it's Gigantocloa atroviolacea. It's a bamboo that grows in Java. It stays as black as it is. So beautiful for furniture, especially. Not so strong, but that's why I have more. So I use just a whole array. Here you can see the joinery. Each screw, each one of those bamboo hollow spaces here, each of those screws goes through the other bamboo, and there is a cement mortar injection. It's a very simple joinery technique, very fast. I don't work these traditional joinery connections. I admire the local carpenters, the local tribe men. They know how to work with the knife. I'm too stupid for that. It takes me too long. I just take a drill and an electric generator, and I just put a screw through it. But my first bridge took 5 months with 25 traditional carpenters, and it was $25,000, and I went broke. And the next time, I did the same bridge with 5 carpenters in 5 weeks for the same $25,000, and I made some money on it. So it is the practice, the experience, and also introducing modern technology to make ancient techniques or slightly modified ancient techniques to work economically. So since then, we have even achieved to do bridges for passengers and for cars, occasional cars. In this case, the ambulance, for example, if you have a school, it could happen that a guy fades and needs to be transported to the hospital. So schools usually need to have ambulance access to everywhere in their school place. So we had to build this bridge in order to go through. And here you can see the bamboo split. There's no glue in this type of flooring. It's all nailed together with bamboo nails. There are a few metal screws you can see here, here. There are some metal, but at the end of the day, it's looking how far we can reach, how we can get real engineering done with minimalistic effort. And my big admiration goes to this kind of bridges. These are bridges how they are made by the tribal people in Indonesia and also in the Amazon in Colombia, for example, where I live now. You see, they use curved bamboo from both sides, they dig it in, and then they have straight bamboos using it as tension wires. This is exactly the same way how modern engineers would build a cable-stayed bridge, like the one we saw yesterday in Coimbra. It's the same logic behind this bridge and the most modern bridge designs that we have. So I decided, when I was asked to build a bridge in a city, I wouldn't come up with this colonial design with those brick tiles on top. It just would look awkward in a modern city to do such a design. So I remember that the traditional bridges in Colombia, they have this arch and those tension wires. So I created rather a sculpture. It's my design. There was no other architect involved but the architect who had to sign the papers. But we hired the local architect. It's same as the engineer also. We just got a team together of people, designed that bridge, signed off the papers. There was no testing, there was no revision by the city hall. Yeah, sometimes third world countries have a very big advantage. A lot of things are possible, which are not anymore possible here or not yet possible here. So this building was done, privately financed. You see here, you use a drill, put a bamboo nail in it, and sometimes even metal screws. We used a metal scaffolding to create some towers, and you can see the cabling here. So bamboo is so light. You can basically lift it up by hand. You don't need heavy devices. You can lift it up with a few pulleys, and then joinery is done by drilling a hole and filling up these, you can see, we fill up the hollow spaces where this screw is. It's filled up with cement mortar, with rather liquid cement mortar, and that gives this incredible strength. I don't know how we could do this more technically. Yeah? Probably we wouldn't use Coca-Cola bottles, but there is a way to inject it. Pretty sure technology would exist here. But you can see those long bamboos here. You can see it better here. It's packages of slightly curved poles. Here you can see the way how the bamboo splits are arranged as, if you put them vertically, they are much stronger than having those splits being in a flattened way. The load test, so the local engineer came by. This was actually the security engineer designed to supervise the project, so I put him to the supervision of the load test, and you can see in his face that he was not really convinced that this building would be standing up, but it did. Having all this water on the most critical point of the bridge, the 30-meter bridge only sank 9 centimeters, which is exactly the 0.03% which is allowed in the building code. So it is possible to use bamboo according to the norms. Just in this case, we built the bridge first, and then we revised if it fits to the norms. And I'm happy that it worked. Obviously, as I told you before, there is no bamboo building without a roof. Bamboo needs roof and needs good concrete footings to be out of the moisture. And then this was built in 2008. It's 16 years now, 26 years. What is it? 2008 until now, 16 years now. And it's still standing. It got painted last year. I think that's important. Yeah, the membrane alone, these architectural membranes, they are reinforced, fiberglass reinforced membranes, Ferrari, French company. They are more expensive than the whole bridge. So just the roof is more expensive than the entire concrete and the bamboo together. Problem. So not really a third world technology, no? You have to have a roof, but all the money you save by using natural resources, at the end of the day, it gets lost in the roofing. Anyway, I did another bridge in Sumatra. This one is for the orangutan haven. We prefabricated it on the site. We had the possibility to get a local crane. Instead of 1 month working on the bridge, we only worked a week setting it up. cement mortar injection down here, up there. In these, even there is a bolt, there's no cement mortar injection needed in these places, only here, 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 and on the top. So it's a question, where are the stress points? Where are the critical points that have to be loaded? And then you see there is a triangular bridge, very interesting concept. We used a local indigenous technique for roofing. You see here bamboo splits. They are just basically hooked on those slats. 15 years warranty, more or less 15 years, but very easy to replace. It was actually very nice that we, instead of using the man, because there were no men available, every man available in the region was working on the heavy-duty carpentry, and we needed more personnel. So we did a few hundred of those tiles, of those, how would you say in English, slates or shingles probably. So those shingles, yeah, we knew, okay, one man can do 100 shingles in a day. Then we asked if they could work that at home. They put their women to work, and the women loved this job because they could watch the children at the same time, and they could take care of the fire because they had so many cut-offs, and at the same time they had an income. And that was something that the men did not like, because we paid the women directly. For each package of 100 tiles that they brought in, we paid them off, and they didn't give the money to their husbands. So we had a serious problem. We were basically undermining the local hierarchy, but that was well-intentioned. Anyway, so this system worked wonderfully. The bridge got built, erected within a week, but basically finished within 3 months, with all the tiles and everything. Beautiful project. Also supported by Lucas Sollinger and by Paneco, which is this orangutan saving NGO. Look, this beautiful idea. The architect, he wanted to have a feature like a skylight in the middle, and he wanted to have a free floating roof, like a cape. And easily said, but for me it was a major problem. Imagine, there's a triangle, okay? But here, in this part, it's a trapezoid. So if you put a lot of weight here or here, either one, the whole trapezoid is deforming. So if you have a triangle, it doesn't matter where you put the weight. But if you have a trapezoid, the whole thing gets a little bit asymmetric. And it was difficult, so we had to come up with lots of those crisscross things here to get it stabilized. This bridge was not calculated, it was all belly or gut feeling, but it was done by a Swiss carpenter and me. So the Swiss carpenter is also architect. So it is good if you have this combination between ancient old practical knowledge plus the design features like having a skylight and these flying eaves. It's a very creative outcome. I think this is a masterpiece because different trades work together and do something, financed by people who want to do conservation, not by people who want to be cheap and ugly, but people who want to give a meaning to use of natural resources instead, or sustainable resources instead of hacking down the last tropical trees. Well, most of you, I guess, know what a space frame system is. Space frame systems have been used a lot in the 20th century. Buckminster Fuller, and Mehringhausen, and many people used these systems, and it's actually nice because you can have a prefabricated truckload of prefabricated elements. You do it all in the computer, you give the measures, and then you set up, like here you see, the truckload of poles is delivered. The joinery is done by inserting a tube into the bamboo and putting a few screws through it, just basically pasadores. And then you set up the structure. This is a different system. This is grid shell with curved elements. You can see that this bamboo, it is the most crooked and the nastiest bamboo that's out there. It's called Bambusa vulgaris. It's all over Africa, and it's pretty much the only bamboo that's in Africa. So it's whenever you have a project in Mozambique or elsewhere, you will face this type of bamboo, and it's a very crooked thing. Terrible to work with, very sweet. The insects love it, and I think not many people have built with this stuff. But we did one with the School of Arts in Vienna. Architect Barbara Muller, she is the one who introduced parametric design to me. I had no idea what was parametric design until I saw a whole bunch of a classroom with something called rhino and grasshopper, and they explained me, okay, this is it. Well, I say, no problem, we can build it. So I laid out the matrix on the ground. Each curve was cut in a matrix of a Cartesian system, X and Y, and then we assembled 3 bamboos to create one curve, and then basically all the curves were set up according to the plans. And the whole system within a few weeks became a self-standing structure. And it became a round or a curved or a shell structure, which was totally new, because until the very last bridge, you can see all the structures were pretty much straightforward, pretty squared, trusses, traditional engineering. And now we're moving into a different direction. And this is the direction which we are facing nowadays. After all these squared buildings, Bauhaus style, now we're going into the extreme other direction. We're going into the most impossible ways of building things. You see these kinds of curves? They are stable. There is triangulation, and they are also kind of beautiful. Not sure if this thing will work. Yeah. This is another way of building with bamboo, something that you could experience here on the campus, because it's the small bamboo that we saw yesterday in the park in Coimbra. So we set up a yurt kind of concept. It's basically 2 fences put together. Voila, there it is. You can have it again if you want, but I think we have to move forward. Anyway, this lecture stays with you, so you can take it home. Yeah, you see now I'm moving into a more curved, more organic, more wavy kind of architecture. And I was asked by Olaf Brun, nomadic architecture in Amsterdam, to help him with some manta ray configuration. So we built this project here. You can look it up on the internet. It's very well documented. It's called Playa Viva in Mexico. Playa Viva, there is a bunch of manta rays that became a hideaway resort. You can see a few features, and I think this is the biggest market for bamboo constructions at the moment. Hideaway resorts, all kinds of beach features, yoga temples, or all kinds of meditation devices. The trick is to do open structures. Don't think in walls. Don't start with windows and doors and all this. If you would like to have windows and doors, do it in traditional materials and just build the structure over it. Build the bamboo structure bigger and do the rest of the rooms that you need in a traditional way, or in adobe or all kinds of rammed earth or whatever. You can do panels like we did here. We did roofing with crushed bamboo and put tar paper, or what is it called, bitumen layers on top. And the walls were designed, they were prefabricated. So these kind of hideaway resorts, they sell for $1,000 a night. So I don't know why there are so many people with money, but there are. Like this barrel, the barrel was on the front page of Travel and Leisure, which is a magazine for the hotel industry. It was on the front page, and within 1 week, this guy has sold out his hotel for the rest of the year. And he decided, okay, if one room like this made such a difference, let's do a few more. And then he called for help. He called for architects who could design in bamboo. And within 2 or 3 months, we had the project ready, and another 6 months to build it. So by end of the year, he had about 12 times the amount of rooms available than in the previous years, and made a good fortune on that. Even if it's not cheap, no? Each of those manta rays was $40,000. Building with bamboo is not cheap. It's much more expensive than with conventional materials, unless you think according to the material. Like this example that you can see here, it is working with straight bamboos, doing curved surfaces in a way that the bamboo stays straight. I was inspired by this Madagascar land turtle, and thinking about how can I work with those thin bamboo poles. They are not strong enough. I have to bundle them, or I have to come up with some kind of this yoga temple needed to be 15 by 17 meters. So I came up with those panels that you have seen previously, and setting up each panel on the side, assembling them, was only possible with these schematic systems. So each hypar or hyperbolic paraboloid is basically a rhombus shape with 2 diagonals. So you have the diagonals from tip to tip, and you have the 4 corners, or whatever, edges, I think you call it in English. So if you have those 6 measures, you can do any kind of hypar within half a day. So this one has whatever, 26 hypars. We prefabricated every one and then assembled that whole thing within half a month. Assembled, not finished, because then the roofing starts. And this is actually what we are going to do, like building 1 or 2 hypars in 3 weeks from now. I have a 1-day workshop in Rotterdam during that bamboo congress in Rotterdam, which is called Bow Meets Bamboo, or Bamboo Meets Bow. What's the way? Well, basically construction meets bamboo, which is the idea to put bamboo into the European context. And next week, with leadership, or let's say with great help from Luis da Gama, we're doing a workshop in Alentejo, in the south of Portugal. I think there are still some 5 or 6 places. So if you would like to participate, I think you can speak to Luis. We will do a 4 or 5 day workshop doing just these kinds of structures. It's the methodological approach how to build such kind of structures in a routine. So basically creating different groups and systematically building these things, and within, I think, 5 days we will have the first part of that structure standing. Here you can see a little bit the size, like the size of those high bars. They can easily have 10-meter poles on one side, and they can be 15 meters long. The whole structure is huge. But as it is bamboo, it is so lightweight that with simple techniques, age-old carpenter techniques from the medieval times, but those techniques allow you to assemble those huge panels in an easy and uncomplicated way. Once they're all brought up, you just put a few screws in, do a little bit of cement mortar injection, and then the structure is ready for thatching. So here you can see a yoga place in Brazil. This is in Guararema, close to Sao Paulo. It's called Terramulungu. It's for all kinds of healing and shamanic rituals and stuff like that. So, yeah, laying there on this floor, looking into this roof is quite confusing, I think. You can get a good trip. So here you see, this is totally new way of doing architecture with bamboo. It has never been done before. And it's so easy, it is so nice to do it with small sticks. You don't have to have those big heavy timbers, because what you're doing, you're creating surface active forms. It's not anymore that one pole is having all the load, it's the whole ensemble, the whole surface is carrying the roof. I think these are pretty much the last pictures. Skylight, obviously, to leave the air out. Night shots. I think that's it. And I will stop here now and give space for questions. And let's start to interact. Thank you. You have light? That's a smart way. Good. Do I have to stay here with the microphone for the people on?
Yes.
Don't see any questions yet.
Thank you, Jörg, for this lecture.
Questions here for the...
I don't know if someone in the Zoom have questions, but I would give the space for the people that are here to make their questions before the people that are in the comfort of their homes. If someone wants to make a question here, I know. Maybe you should come here so the people in the Zoom will see you.
Or maybe you bring the microphone to him,
of course, but
and
the
I can
people
answer
in the
from
Zoom
here.
won't see him. But
Yeah.
that's a possibility also. As you...
Here. You're more photogenic here.
Okay, so you can see us both. Thank you for the amazing presentation. It's really, really, really interesting. What I was wondering is, the first thing is about the maintenance of these structures. So how long do they last? Because it's a natural material, right? So you talked about bugs and termites and stuff like that that can eat it, but I guess that they will need some kind of maintenance. How is it made, and how long does one of these structures last? And then I had another one which was about the joints, because the method is really interesting. But at some point you showed some joints that were, I don't know if you can call them joints, but they were basically ties and knots that tied the pieces of bamboo together, and you didn't use nails. To me, it looked more natural, but when do you pick one over the other, and why?
Yeah. I guess there are at least 1,000 ways to join bamboo. If you go through the different cultures around Earth, you have very cultural specific joineries, usually made with a knife or made with bamboo nails and ropes like coconut fibers or whatever. Yeah, you can do that if the client wishes so. I would not say it's more natural. It's using more natural materials. But sometimes those fibers, if you don't have a stick in between, bamboo shrinks about 10% in the process. So when you do it with fibers, tying it down, it gets loose over a while. So it's very important to have those bamboo nails going through that joint. And then you can do additionally some fibers. Instead of putting screws on both sides, you could use fibers if you wish so. These are more, let's say, modern ways. Like using a screw is a more modern way, but you can also use the cement mortar injection inside. So you put just a rebar, not a screw, but a rebar, using it as a nail or a bolt, cutting it flush and putting the cement inside. Then nobody will see how it's joined. And if there is not so much pressure on that joinery, if you don't have tons working on it, just a few hundred kilos, you could use just bamboo nails in a crisscross way, like put your arms like this. With a screw you go like this, but if you use bamboo nails you would go from here and from here in diagonal, and they're crossing over, and then you have a very natural way of joining it, but not using any cement or other things. Yeah, but it is limited maybe to 200, 300 kilos depending on the species you're using. But with the cement injection you are talking about 2 tons or 3 tons. Yeah, so it's 10 times the amount. When it comes to engineered structures like bridges or big buildings, it's not only that it has to be natural, it also has to be functional, reliable, durable, which leads us to your first question, which is about maintenance. If you have a nice roof and if you have nice concrete footings or stone footings, there is zero maintenance.
Zero maintenance.
Zero. You can paint it after 2 or 3 years, but it's an aesthetical thing. If there is no rain, no sun coming to the bamboo, you don't need any maintenance.
It's amazing.
If you do the treatment first, yeah?
Yeah.
The same with steel structure. If you don't have rust, why would you do maintenance? Yeah?
Right.
But if you expose it to the elements like rain and everything, even a steel structure would rust and get rotten over time.
Yeah. But since it is a natural material, I thought that it wouldn't last that long.
Take the idea of natural steel. It's natural steel. Timber structures, wooden structures here in Porto, they may be, some roofs may be 500 years old.
Yeah.
If they have a closed roof, they can easily, wooden structures can easily be 500 years old. You remember the bridge, the wooden bridge I showed?
Yes.
That's a 350-year-old bridge. No maintenance.
And it's still there.
Yeah.
Amazing. Thank you.
So,
Welcome.
any more questions here?
Maybe there are questions here, but I just don't know where.
Eu. Só minuto, deixa eu só ver. Aqui. Não, ok. Depois?
Um,
Ok. No.
Okay, so what's the question?
here, I'm waiting for the sign to. Can I speak? Can I ask?
Yeah.
Okay, sorry. So my question is, so you were talking about the idea of, or like the work of having bamboo structures also here in Europe. And my question is about the material of the bamboo and the ecological like the ecological thought behind, and what is your idea of importing, if there are local bamboo species that can be used for this kind of structures, and if not, what is the impact of importing bamboo from other countries, from Asia, for example, to Europe, and the ecological impact this could have on our environment, like other species that we import and then have a invasive behavior in the local environment.
Yeah. So there is one big project here, it's called Bamboo for Europe. It has been a EU-funded research, and I think the output was, yes, bamboo grows in Europe very well, reasonable growth rate, good CO2 fixing. It grows very well in Greece, Italy, Portugal. We have big forests in Portugal, actually in Alentejo. They have 150 hectares of big bamboo growing. In France, we have several old castles where we have 150-year-old bamboo stands in those botanical gardens. So there are applications for bamboo fibers, not necessarily for round bamboo. So you can use bamboo fibers as industrial resource instead of using steel needles. For example, you have cement, you put those steel needles in the cement, and then you can do sculptures or plastering with structural concrete, beton. And you could replace, for example, those steel needles with bamboo needles, with bamboo fibers. That's scientifically proven. It's just too expensive at the moment because we don't have enough bamboo fibers to do it in a big scale. So Bamboo for Europe is basically looking into promoting bamboo, so we could use not farmland but forest land and use it for bamboo production in Europe. And regarding those round poles, I would not go for your typical mindset of doing housing or something in bamboo. I would go for open, free-standing things like carports or like meditation halls or like tea houses in the parks or something. It's just a question of design, if it is accepted or not. For example, the Queen of England has, she was in love with bamboo, and she has her tent structures behind Buckingham Palace. She has always bamboo structures behind Buckingham Palace, but using Ferrari tents, like a circus tent, basically. And I think there are lots of events, like all kinds of event happenings, music festivals, they easily could use bamboo as a resource.
It's interesting to hear where there's the potential application for bamboo, but also my question was in direction, what is the ecological impact of importing species from other countries?
Yeah, species or poles?
Which grow actually quite well.
Green species, is your question going into the gardening? You're questioning if it makes sense to bring in new species into Europe for growing it here? Or is the question going into the economical or CO2 impact of transporting bamboo poles from third world countries into Europe? Which part of the question?
So I think if you want to build in Europe with bamboo, it would be most logical to grow the bamboo in Europe and not to import it from other countries.
Yes, but yes.
And then, so my question was about the fauna and flora.
Yeah, I think fauna and flora is not such a big problem because if you take in mind that tropical bamboo grows like a flower pot. It doesn't grow in all directions, while subtropical bamboo or bamboo from temperate climate like northern China, Mongolia, they grow like a rocket underground and come out on the other side of the road. These temperate bamboos, they are not suitable for plantation in Europe because they could take over, they wouldn't take over the whole countryside and the nature, but they would take over your neighbor's garden. So in the past we had a lot of those Philostachys genera growing here, the same one that grow in the botanical garden. You started them on a little plot and they're taking over along the greens, wherever you have a lawn, they could easily take over the lawn. But they will not take over, let's say, an oak forest or something. So wherever you have grass, yes, those temperate bamboos, they could take over. But if you have tropical bamboos, like here in southern parts, or like the Mediterranean environment, those bamboos, they stay in the place where you plant them. So it's a different genre, a different species.
Okay, thank you. It's good to...
Can you make it happen?
No. Who wanted? Was another question?
Yes, there is a question here in the chat saying, hello Jörg and everyone, thank you a lot for this precious sharing. I would like to ask, what's the best treatment for bamboo, method for bamboo to last longer? You right mentioned that during your conference, but...
Well, there are many methods to make bamboo durable. You can have oil-based treatment, which would be basically some kind of typical wood treatment like cypermethrin, dipermethrin, all kinds of pyrethroids which are used all over the world for wood treatment. And you can have water-based treatments which usually work on salts, like bitter salts, like for example boron-containing salts. That works very well, but it requires that the bamboo is soaked for a few days in that salt, in a 5% at least, or maybe 10% solution for a few days. Or at least if you heat the water up, you can do it for an hour. In warm water, it goes much faster. But the problem is that you have to dry the bamboo afterwards. So it makes sense immediately after felling, after taking the bamboo out of the forest, you should do the treatment immediately. And also there is another question from Raul Lopez. He is wondering how much water is needed to grow bamboo. And I can basically say yes, it's a lot, and it's a negative impact. But you have to question how much water is needed to grow a pine tree or another tree. So if you go for the logic, it is 3 factors that make a plant growing. It's the substrate, the soil where it grows in. It's the heat, the sun, basically, the temperature, the sunlight available, and it is the water availability. So these 3 factors make grow biomass. If you want to grow a lot of biomass, you need a good soil, you need warm and hot sunshine, and you need a lot of water. It's exactly the same with eucalyptus, with pine trees, with any other kind of biomass production. If you want to produce biomass, it just needs those 3 factors. So if you compare, for example, some people, bamboo grows 8 times faster than a tree. That's wrong. That just doesn't make any sense. Yeah? If it is in terms of biomass production, you have to compare the same environment, the same soil, and the same sunshine. So you have to ask what plant is growing faster in this environment. And for example, in Colombia, where I live, we have Guadua angustifolia growing naturally. It grows something like 17 cubic meters per hectare per year. Pine tree takes 25 cubic meters per hectare per year, and eucalyptus tree is something like 39, almost 40 cubic meters per hectare per year. So if you compare those three, this type of bamboo is not growing as fast as the trees. Actually, the eucalyptus tree is taking the lead. The pine tree is even ahead. But the pine tree and the eucalyptus tree also consume 2 times more water than the bamboo because they grow faster, they need that water. Yeah? So if you would use Dendrocalamus asper, which is a bamboo from Bali, from Indonesia, it grows twice as fast as guadua. It produces twice as much biomass per hectare per year, and it uses twice as much water per hectare per year. So you cannot simplify and say, bamboo uses a lot of water. There are some projects in the desert around Abu Dhabi. They are planting bamboo in the desert. Where does the water come from? It's from the shit and the urine of the city. So basically, what are you doing with all the water, with all the effluents of Abu Dhabi? You can send it into the desert and make a greenhouse. Just don't eat it. Yeah? So you can do, there is a lot of water. You just have to think what I'm doing with the wastewater. How can I use bamboo for wastewater management? And then the question, if it sucks up a lot of water, is not any more relevant because it does good. It creates biomass.
I would like also to make a question, which is, you spoke a lot about the possibilities of bamboo and also about some limits of bamboo, like for walls, it's not good, and this kind of stuff. And in terms of programs, what you showed is some social projects, we would say, some reunion centers and this kind of stuff, and these very fancy hotel rooms for rich people, as you said. And both of them, they are in more, not rural, but not urban for sure, environments. So do you think that the bamboo has a place in the city? And if he doesn't, this is due to the nature of the material or to the architectural culture that doesn't allow to have natural materials in the city?
Look around here in this lecture hall. What you are sitting on is a natural resource. It's wood. On the walls, we have wood as a decorational panel. Yeah? The floor is made out of wood. All those 3 products can be made out of bamboo because we have industrial processed bamboo laminates. If you go to Moso International or some website, you can see that there are all kinds of products. Pablo van der Lucht wrote a book, it's called Booming Bamboo, and it shows about 20 different industrial processed bamboo products like wool, for example. You can make bamboo t-shirts or towels or all kind of stuff. It's not so much a question of what you can do or what you cannot do. It's rather a question, do you want to use a bamboo industrial processed with all the related contamination and the related energy impact, or do you rather want to have a natural bamboo construction? I, today, was only talking about how to build with bamboo poles. I did not touch the industrial uses. A lot of people use bamboo flooring in Europe. It's a fashion flooring, for example, for stores, for high-end stores of certain fashion brands. They use this very nice, clear flooring to call people in. Like in the shopping malls, you can find all of a sudden a very nice, beautiful wooden flooring, and it turns out it's not wood, it's bamboo. But these are design features. In terms of housing, there is a company, like I mentioned, Bamboo Living. They do housing, but it's not for the center of the city. It's not urban environment. It's rather suburbs, like individual houses in a park. Somewhere in you know, the US has a different concept of housing. So there they work very well, and those panels They are prefabricated panels. They come in completely sealed against heat, against rain. They are just screwed together, and you do basically your kit. You buy your kit to build your house, and it's perfectly up to the millimeter. It's set up, prefabricated, but that's what makes it expensive. Maybe on a future opportunity you could invite Luis Felipe Lopez from Base Habitat, or is it called Base Baha'i? I think it's Base Baha'i in Philippines. They do hurricane-safe housing in small villages. They do entire villages in bamboo, and it has been socially accepted. Not only accepted, people really want those houses nowadays, because after a few hurricanes went through, only the bamboo houses were the last ones, or were the only ones standing. Not even one house got harmed through a hurricane. So they developed a really convincing housing concept for social housing in small villages. How to bring that to the next level would be 2-story, 3-story, 4-story bamboo houses. But I think that the market at the moment is not ready for that. In France, Sweden, Holland, Germany, we are going now for wood panel houses up to 50, 80, 60 floor high wooden houses. Wood cross-laminated timber is now ready for multi-story buildings. We could theoretically copy that concept into bamboo, but I think at the moment we do not have the amount of resources needed to attend such a boom. So I don't want to call the ghosts, because maybe later I have to deal with the consequences. But once projects like Bamboo for Europe or something, once they have hundreds or thousands of hectares of bamboo available, these possibilities of cross-laminated timber or mixes like hybrid panels between bamboo layers and pine tree layers, pine laminated. I think those hybrids exist. There's one company called BAMCore. They have the core of one of those wall panels in bamboo, and the rest is just veneer, like wooden veneer. So initial possibilities are already on the market, but we don't have the resource at the moment, because the big bamboo forests of the world, they are in the most remote areas you could imagine. In the middle of Amazon, we have 1 million hectares of bamboo, but we cannot get there. Acre is too far away. No? It's 8,000 kilometers away. You have to be weeks on a ship to get that material out there.
How I learned that almost all the wood moves a lot with humidity changes and temperature changes. How is this? How does bamboo react to humidity changes and
same like
temperature?
wood, same like pine tree, like Fichte or like any kind of softwood. It's bamboo grows very fast. If you maintain it dry, it lasts long. If you get it exposed to water, there's no future.
I was talking about the movement of the bamboo, of the expansion and the torsion of
no torsion. There's no torsion, and there is like between 5 and 10%. What is it called? Shrinking. The shrinking and the swelling of bamboo is around 5%. Same like any kind of wood. If you put a bucket full of water on this floor, it will pop up.
Yeah.
The same would happen with bamboo.
But the torsion part is not here.
No torsion.
It's not there. Okay.
No
so
torsion.
that's a positive point for the bamboo, because in cross-limb or in
bamboo doesn't have radial fibers. You remember that bamboo is very bad in terms of splitting. Because it doesn't have radial fibers. Wood has radial fibers, so wood has length fibers, and also radial fibers. Bamboo doesn't have radial fibers. That's why it's so easy to split. It's like grass.
Okay. Because what I think we observe with the wood here in Portugal is that the wood has a very strong torsion movement, which makes it harder to be used in
what I was mentioning to you about
buildings.
the fagus tree, the beech tree. Yeah, it is a lot of torsion in wood, in some kinds of wood. Bamboo doesn't have that factor. Yeah, but if you create industrial lumber, if you create cross-laminated bamboo lumber, you would have 60% to 70% sawdust to create 25 or 30% of net output. So if you have timber, you have probably 50% sawdust or cut-offs. To make a round tree squared, you have around 50 to 60% cut-off too, and only 30-40% are net output. So it is a little bit higher. The net output of trees is a little bit higher than the net output of bamboo. But there are other technologies, for example, scrimba. Scrimba means scrap timber. I think it's an Australian patent. Nowadays they call it bamboo extreme. It's the Chinese call it woven strand board or strand woven board. They crush the bamboo splits and put it in a big press and squeeze it together so it becomes a block, and this is like 60-70% output, so you have very little waste material. So there's always, in the technology, there's always an advancement, but it doesn't help us too much because only the Chinese have enough bamboo forests. They did not have so much bamboo forest, but after the Cultural Revolution, they noticed that there was no forest left in China. So during 20-30 years, they just had to import pulp, paper pulp, from Chile to print the Mao Bible, for example. So the core of the religious belief system of the Chinese was the Red Book of Mao. And they had to import the paper basically from Chile to print that stuff. And they noticed, no, this cannot go on. We cannot just produce rice. So they converted some of the rice paddies into bamboo plantations. And nowadays they have probably, I think, 10 or 20 million hectares of bamboo under production. And they converted many rice paddies which were not very efficient in rice production because they were somewhere in the drier areas. They converted them into bamboo production. But that is a 30-year movement of planting. Every month they had to plant and to plant and to plant. And now, 30 years later, now they have enough resource. They are the leaders, world leaders in bamboo production, an entire industry based on bamboo. And this is something where I think the idea of bamboo for Europe is just important. We have to start now to plant something else than just eucalyptus trees. Portugal is full of eucalyptus trees. One big fire and it's all gone. Bamboo forests don't burn. Yeah? So it's a good possibility to convert a big part of the eucalyptus trees into bamboo forests, and you will have pretty much the same output. So there are possibilities to think about it, but we are in the beginning, we're in the initial stages of those kinds of conversion.
This was actually my concern when I asked about the bamboo species, how is the effect of the environment, the local environment, is that it will just be a substitute for eucalyptus, which is a very, very harming.
It's the same. In terms of water consumption, it's the same. Yeah, eucalyptus trees, as I told you, it's about biomass. Biomass production and water consumption go along. So if you have bamboo, it will also take a lot of water.
And why do you say the bamboo wouldn't burn like the
Because it
eucalyptus tree?
stays green. Eucalyptus goes dry and the branches fall off and they create an underlayer of branches. And eucalyptus forests can burn, but the good thing about eucalyptus, if they just have a quick fire, they can re-flourish, because in Australia wildfires are pretty normal, so the plant is adapted to wildfires. But bamboo, for example, bamboo doesn't burn because there are no branches on the ground. It's all green and fresh, and it just doesn't burn. At least not in the tropics. I don't know. But here I think the same. If you go into the botanical garden in Coimbra, you see a few dry sticks, but I don't think it's enough to create a fire or to maintain a fire.